Hi guys, here I am going to present electrochemical cell. Electrochemical cell can be bifurcated into galvanic or voltaic cell and electrolytic cell. Alright, now let's check out galvanic or voltaic cell. Voltaic cell or galvanic cell has two compartments. This has got zinc sulfate as electrolyte, this has copper sulfate as electrolyte. It has got two electrodes. This electrode is made up of zinc, whereas this electrode is made up of copper, and it is connected to voltmeter. This is salt bridge which maintains electrical neutrality. Alright, now let's understand the reaction. This is the reaction which occurs over here. Zinc reacts with copper sulfate to yield zinc sulfate and copper solid, zinc solid. Now zinc gets converted to +2 oxidation state. So it has lost 2 electrons. So that's the reason why this is called as oxidation. And this is what is happening over here in the half cell. So it is known as half cell reaction. That zinc solid on oxidation gives Zn2 plus 2 electron. Now what happens to copper? Let's understand the fate of Cu2 plus. Why Cu2 plus? Because it's copper salt and it is in aqueous solution. Obviously this has to be 1 molar if it is in standard state. Alright, so Cu2 plus gets converted to copper solid. So how is it happening? It is gaining 2 electron which zinc has lost to form copper solid. Alright, so this is what is happening in this part of the cell. Now this is half cell reaction, of course, at cathode, and of course reduction. Alright, so let's understand here. What happens is zinc metal gets into it, loses its 2 electron, passes from here. This 2 electron comes over here, and Cu2 plus is waiting here to collect those electrons. And on collecting those 2 electrons, what happens is it forms solid, copper solid. So it gets deposited over here. So zinc's electrode keeps on reducing in size over here, whereas copper electrode cathode keeps on becoming thicker and thicker in size. Alright, so that's what happens over here. Now another interesting thing that we observed is here the chemical energy is producing electrical energy. Alright, so that's what it is. And anode is negative over here, cathode is positive over here. Now let's get into electrolytic cell. In case of electrolytic cell, we have fused sodium chloride, 2 carbon electrodes, and NaCl splits up into Na plus Cl minus. Now let's understand what is half cell anode reaction, or rather oxidation. Cl minus loses electron to form Cl atom. Another molecule of Cl minus loses another electron to form Cl atom. 2 atom combines to form Cl2 gas, and this Cl2 gas is liberated at anode. Alright. Then what happens in case of cathode? In case of cathode, it is sodium which is there. Sodium gains electron. Now it has lost 2 electrons, so I can jolly well put here 2 sodium ion gains 2 electron to form 2 sodium metal. So sodium metal, silvery white sodium metal deposits over here, and we have chlorine gas liberated over here in anode. Another interesting thing that is that here we have studied in school, you have studied in school that anodes are negative, but it's not true. Anode here we find is positive as it is connected to positive terminal of external cell, whereas here since it loses electron to the electrode, so here anode is negative. Okay, that's one thing. Another important thing is here it is the electrical energy which is carrying on this chemical reaction, or electrical energy is converted into chemical energy. Fine, so that's what happens. Now let's focus into galvanic or voltaic cell. Now we are talked about cell. So if we are talking in terms of E0 of cell, what do I mean by E0 of cell? That means standard. Standard is when the reaction is carried out at 25 degrees Celsius, 1 atmosphere pressure and 1 molar concentration, then we call it as E cell. Assume it's all valid for this reaction, so E cell would be equal to E0 of anode plus E0 of cathode. Now we know that E0 of anode is oxidation potential, whereas cathode is reduction potential. Alright, now we have a table called ECS, electrochemical series. Electrochemical series gives us only the E0 reduction. Alright, so what do I do? Now I need to tell you something, that if in case of if the EMF required for a particular reduction is say 2.5, so for the same reaction when we go back, that is when we do oxidation, it would be minus 2.5. If for a particular reaction say Mn plus N electron gives you M, this is what? This is reduction. Suppose for this reaction the EMF is say 2.7 plus 2.7, then for backward reaction, that is for oxidation, it would be minus 2.7 volts. Okay, so what do we do here? So we have got to refer ECS, and ECS has reduction potential. So in order to change reduction potential to oxidation potential, so what I would do is I would put in minus and I would put here reduction. So whatever is in the table I would use it, but I would multiply it with negative sign. So as a result of that, this would be the oxidation potential plus E0 reduction. This we will directly get from table of ECS, whereas this we would get reduction potential from table, we will multiply it with minus, so that becomes oxidation potential as explained here. Alright, furthermore I would be carrying out in my next video. See you then.